Good afternoon to all my dear students. As in the last classes we studied about to find the inverse of a matrix by elementary transformation. I told you on that is the shortcuts which you have to remember and step how you have to find the inverse of any matrix. So first I told you that what element is there, first element you have to make first element as a 1. Then after second step, in second row first element you have to make as a 0. Then third you have to make this step as 1, and then after that this as a 0. It means what is the step? This is the first step, you have to make first element as 1. This is the second step, step 2, you have to make this element as a 0. Third step to make this element as 1, and fourth step is to make this element as a 0. It means you have to make here identity matrix 1 0 0 1. This is for the 2 by 2 orders. And now the next step I am taking for the 3 by 3. In 3 by 3 first step is you have to make 1 here, then 0, and third step 0. This is the step first, then second. After that, like W, this is you have to make 1, then down 0, then 1 0 0 and 0. This is the step. It means you have to make here like this type of W. Clear? So this is your first step. This is your second step to make it 0. In first step you have to make element as a 1, and second step, this is your first step, this is your second step to make this element as 0, this to make as a 0. Now this is your fourth step to make it as 1, then this is fifth step to make 0, then sixth step to make as a 1, then seventh step 0, eighth step 0, ninth step 0. So you have to end with this. These we have to make with the help of elementary transformation, as we did 3 for the row transformation and 3 for the column transformations. And as I told you already that if we are taking the row transformation, then A is written as IA for row, and for column it is written as AI. So let's see how to do by using this concept the questions. So I'm taking the first question here of 2 by 2 orders. See, matrix A is 2 3 5 7. It is 2 by 2 orders, and we know what is our target: to make first element 0 0 1 0 1. So this is our first step, and this is second step. So here in first step there is A is 2 3 5 7, and we can write A is equal to IA. It means I'm taking the row transformations here. So here elements are like this. Our target is to make this element as a 2, this element as a 2. So to make it as 1, first element as a 1, what I'm doing, there is two way. First two by dividing by 2. Yeah, second way is to take interchange the rows. So I'm taking here the interchanging the row concept. So I'm interchanging the row 1 to row 2 and row 2 row 1. So by doing this operation I'm getting 5 7 2 3 0 1 1 0, because here also you have to do the interchanging. But so operation we are doing left side, same operation we have to do on the right hand side also. So now here, now my target is what? First target is to make it is 1. How to make it is 1? We know if I will subtract this 5 with 4, then I will get 1. So for that it means I have to multiply row 2 by 2. So now I'm applying by using that operation R1 on this R1. R1 is R1 minus 2 into R2. So R1, 5 minus 2 into 2 4, 7 minus 3 into 2 6. Similarly here 0 minus 2 and 1 minus 0. So now we did the operation on R1, so we have not to change anything on the R2. R2 will be as the same. So by this we got here 1 1 2 3 minus 2 1 1 0. Our target is what? To make these elements, first element as 1, now second is to make it a 0. How it will become 0? For 0, but 2 minus 2, we know 2 minus 2 is 0. It means for making 2 minus 2, we have to apply this operation r2 minus 2 into r1. 2 into r1 means r2 minus 2 into, with this we have to subtract. Then by doing this, and again we are doing on the r2, so we have to apply only the r2. R1 element has the same, like this. So here 2 minus 2 into 1 2, 3 minus 2 into 1 2. Similarly minus 2 minus 2 1 as it is, and then here 1 minus minus plus 2 into 2 4, then 0 minus 2 by using this operation. So it become 1 1 0 1 minus 2 1 5 minus 2. Now we got first step 1, this 0. Now our target is to make it a 1, so it is already 1, so it reduces our labor work, and it already we got to 1, so no need to do anything here. So now we have to go to the last step. Last step is to make it a 0. So to make it 0, how it will become 0? If we subtract these two, then it will be 0. So it will become 1 minus 0 or 0 1 minus 1 minus 2 minus 5 by using this operation r1 on r1 minus r2. So by this I'm getting here 1 0 0 1 minus 7 3 5 minus 2, and then this is identity matrix. We can write it as I is equal to minus 7 5 3 minus 2a, and then A inverse is minus 7 5 3 minus 2, and this is the A inverse. And one thing I have to tell you that in this elementary transformation, if we are finding the inverse of any matrix, we have to use only the one type of the transformation. That means if we are using the row, then we have to solve a whole question with the row transformation. If we are using the columns, then we have to do with the column only. We have not to do the row and column mixing. We will not mix the row and columns concept. So it is very important point here, and the shortcut for that is, I told you already that first step 1, this, then second this step we have to make 0, then this we have to make 1, and this we have to make the 0. Now let's see the how to find the inverse of a 3 by 3 square matrix. So for that we already discussed with you that this is the shortcut. By these steps we have to start to make first step as the 1, then this 0 0, then after this 1, this is the 1, then 0 1 0 0 0. So these are the steps of the shortcut for this solving the 3 by 3 order matrix. So see here, matrix A is of this type, and again I'm doing the row transformation, so I'm writing A is equal to IA. That means I'm solving this question by only the row transformations. So now see here, what is the problem? First element I have to make 1. Again there is two possibility, by dividing, by addition or subtraction. So if I will do the by dividing, then it becomes 1 upon 5, and then what problem is we are facing, what problem we will face here? Then we have to face the problem of subtraction of the two number, that is 1 by the whole number and 1 in the p upon q form. Then it becomes a little bit lengthy or tough. So better to do simple, try to avoid the division. If it is not possible to avoid the division, then only that you have to use the division concept, otherwise just simple by plus and minus or multiplication. So here see, to make it 1, we can do one thing here. If I will add all these and we subtract from here third rows elements, then it automatically will comes 1. So I'm applying here the operation row 1 r1 plus r2 minus r3. By doing this 2 plus 2, only I'm using this operation only the row 1 both side. So and row 2 and row 3 element will be the same. So only applying the row 1, but I'm getting 2 plus 2 minus 3, minus 3 plus 2 plus 2, then 3 plus 3 minus 2. So and similarly here I'm getting this. Then after doing this, I got here 1 1 4 2 2 3 3 2 minus 2 2 and 1 1 minus 1 0 1 0 0 0 1. Now I got first step 1. Now I have to make it as 0 and this also as 0. So I'm doing here the two steps together. First is on I'm applying on the operation on R2. By applying on R2, what operation I'm doing? R2 minus 2R1. That means the first element will remain same. We are applying only the R2. So it means 2 minus 2, 2 minus 2, 3 minus 8. Similarly here 0 minus 2, 1 minus 2, 0 plus 2. Why? Because we are using this operation. Now only on the row 3 we are using this concept R3 minus 3R1. So 3 minus 3 minus 2 minus 3, 2 minus 12, and then 0 minus 3, 0 minus 3, 1 plus 3. So by this I got here 1 0 0. So I got this step. This is first step. I got 1 0 0. After my step is to make it as 1, but here is already 1, so it is not possible to make it 1. So to make it 1, I have to interchange these row. If I will row R2 and R3, I will interchange, then I'm getting minus 5 here. Then here also by interchanging these operations we will got this thing. So now my target is to make it 1, but it is not possible. How to make it 1? By dividing only it is possible. So for that, what I will do, I'm applying the operation R2 is equal to minus R2 upon 5. So by using this I got like this. So here minus 5 upon 5, minus 10 upon 5, minus 3 upon 5, minus 3 upon 5, minus 4 upon 5. So after this solving this, I got 1 0 0 1 1 1, sorry 0 4 2 minus 5. So here this. So now this comes 0, this comes 1, this comes 0, this comes 0, this comes 1, this is already 0. Now our target is to make it 1 according to this concept. Now we reached here to make it 1. So to make it 1, how we will make it 1? By dividing. Why I'm making adding? Because if I will add, then it will come again here. So we have not to spoil this position, because already we got there in this form, our requirement form like this. So if I will add, suppose if students are thinking why we are not adding these two, but if I will add these two, then this element comes in this place. Our target is to make this side as a identity matrix. So for that I will leave the concept of adding here. Now I will use only to change this. For that I will divide this number by again minus 5. So I'm applying these operations here. So by applying these operations I'm getting this 1 1 1, because I'm not applying any operation on the row 1 or row 2. I'm applying only the row 3. So only the row 3 elements is changing. 2 upon 5 minus 2 upon 5 2 upon 5, 1 upon 5, and minus 2 upon 5, because I'm dividing with minus 1 upon 5. So after that I got this thing. So now my next target is to make it 1. So to make it 1, to make it 0, if I will subtract these two by multiplying this by 2, then definitely I will get the 0, and it will not affect the other elements also. So then after that I am applying using the operation R2 minus 2R3. So by this I got here like this 2 minus 2, and it will not affect the other elements position here. So here by doing these operations I'm getting 1 1 4 1 0 1 0 0 0 1, and here by simplifying I'm getting this. So now the next step is to make this element as 0. So to make it 0, I will do one thing there. What I will apply on R1 minus 4 R3, R1 minus 4 R3. By using this, what I got here, this 0 0, and here 1 minus 8 upon 5, 1 minus 4 upon 5, minus 1 plus 8 upon 5, and these elements as 8. Then by simplifying this I got at last these elements, and now our target is to make this element as a 0. This is our last step, then it become identity matrix. So for that I know how to it will become 0. If I will subtract with the row 2, then it will come 0. So by applying operation r1 on r1 row, r1 r1 minus r2. So by this I got this, and after simplifications we got in this side as identity matrix 1 0 0 0 1 0 0 0 1. And so as I take this element to the side, then it becomes A inverse. The A inverse is 1 upon 5. I took the 1 upon 5 common, then it becomes minus 2 0 3 minus 1 1 0 2 1 minus 2. So in this way we have to find the inverse of a 3 by 3 order matrix. So now there are some questions. These are the questions which you have to try this question for your practices, and then if you will get the answer all of these questions, then definitely that this concept is clear in your minds. And one more thing I have to tell, that if in any questions when we are doing the row transformations, elementary transformation, if we will get any elements whether in 3 or all elements 0, all the row elements 0, all the row column elements of any columns 0, then the inverse of that matrix does not exist. You can see here, if all the elements of these are coming 0 in this side, that means the inverse of that matrix does not exist. So thank you and have a nice day.